Hey everybody, today I just want to do a quick video on the command pattern in LabVIEW. So this is an object-oriented design pattern that you can use in your applications. So just a little bit of background first before we get started. I want to look at, this is the queued message handler template that ships with LabVIEW. So this does not use the command pattern in it, but I want to use it to highlight how you could use it in like this scenario. So let's go open this up first. Yeah, so here we're creating our message queue. So you can see we've defined the type as a cluster of a message, which is a string, and message data, which is a variant. So that way you can basically send a command and you can send any data that you want along with that. So using the command pattern, the difference would be rather than this data type, we would be passing in a class. And so we're going to create an abstract parent class that is, and then we'll create children that have specific, overwrite methods for that, and they can use their own data and whatnot. And I'm going to show you that in just a sec. But just know we're going to be replacing this with a class. And I'll show you that in just a sec. The other big thing we could change, right? So instead, because this queue now holds a class in it, rather than passing in like a string and a variant into these queues like this, instead we're just going to be passing in an object. So we're going to be passing in the specific child that we want to implement. And again, don't worry if that doesn't make sense right now. I'm going to show you in just a sec. But yeah, rather than, this data type, we're going to be passing in an object. And the other big difference is down here in the message handling loop. So essentially everything that's down here could be replaced with the specific implementation of the child. And I'm going to show you that again. Just know this is what I'm talking about, right? We kind of have our DQ here that's just pulling out anything that comes into the queue, and then we're breaking apart that cluster into message and data. And then we kind of have this case structure. So based off the different messages, it can do different stuff, and we can pull out the data. For cases that need data, we can use it, and for cases that don't, we just ignore it. So yeah. Queued message handler works great. The command pattern just is another way to do something, and there's pros and cons of both, right? With the command pattern, especially if you have a lot of cases, you end up with a lot of classes. But if I create a new, like for example here, if I need to create a new case, I have to go to my case structure and add a case, and then fill it out and then put the implementation here. If I actually have this all class based, I can just create a new child class, and then I just need to have a way to get that child class into the queue, and then it'll actually handle everything for me down here. So I don't actually have to do editing of the message handling loop directly, just for the specific child class implementation. So there's some pros, some cons. So yeah, let's take a look at a simple demo I put together for the command pattern. So I've created just a whole bunch of classes. So let's go look at the class hierarchy. So we have, I created this command class. So this is our abstract parent. So this is just a placeholder, really, just to create this hierarchy. This one doesn't actually do anything itself. It just has a single dynamic dispatch method. And that's not to say you have to only have a single dynamic dispatch method. You can actually have lots. In this simple example, I just have a single one though. And then I've created different children that do different things. So, and they all just inherit from command. So yeah, if you open up command, I just have, like I said, a single dynamic dispatch VI called execute, which does nothing in the parent implementation. But then I have set up all these children that can do additional things, right? So our initialize will overwrite execute, and instead it's going to output this message, and it's going to not output a shutdown. and on and on. I'll show you the rest of these here in just a sec. So let's look at our little demo. I tried to keep it simple to make it easy to, kind of follow along and understand. So yeah, we have basically an event handling loop and a message handling loop, pretty much just like the queued message handler. And yeah, I also did add a link here on LabVIEW Wiki. There's a little, just a few lines of just additional information on the command pattern if you're interested. But yeah, so I've created a queue, and as the class, or as the data type, I've put in the command parent class. That's going to allow me to put any of the children in. You'll see that you get a little coercion dot. If you really wanted to avoid that coercion dot, you can do like a 2 more generic and 2 more specific afterwards. But yeah, I don't really care, so just leaving it. It's not gonna break anything for it to be there. So yeah, create my queue. I'm putting in that abstract parent class, and then I can enqueue the different child classes that I want to use. And then down here in the message handler, I have the parent method that is execute, but then I can pass in specific implementations of other ones, right? So right here, right, we're issuing a GET request to this API, and then parsing the JSON and then pulling out the text, right? So they can all have super different. We looked at the initialize earlier, right? We're just outputting a constant string. I've got this dialog one, so we're actually pulling something out of the class private data and writing it to a 1-button dialog. For fail, we're pulling a result out of the class private data, formatting a string, and then outputting that. For pass, we're doing the same thing. And then I also have the shutdown case that just outputs a true. So that's what's actually going to shut down our message handler. And then up here, I just have different scenarios. So right before this even starts, we're initializing the init, which is just going to put an initial message in our little message box. And then as different user interface actions take place, right? So if I click pass, I'm going to load the pass class into my queue. And I actually am able to use additional methods as well for stuff before and after, right? So I added this save result that's part of the class, and all it is doing is putting a random number in there. But that's a way that I can pass any amount of data in between these two loops, right? So in the queued message handler template, we're using a string and a variant. Here we can use class private data to transmit any data that we want from this queue to this queue. So again, we still have the flexibility of being able to put anything in and get anything out, but we're also able to abstract the actual functionality here. So these things can do entirely different things. So yeah, if we look at fail, I'm doing the same thing. I've got the class. I'm calling this method that puts a number into the result field. Again, just a random number for simplicity. For dialog, I have this add message function where I can pass in any message I want. And that's what's actually going to get enqueued, and then that's the message that will be displayed. For fact, I'm not doing anything because it just does some action. So this way, I'm just passing the class, and it will force the action to take place. And then for shutdown, I'm passing in the exit, and that's what's actually going to stop my message handling loop. So let's just demo this real quick so you can see what it looks like. So I run this and I see immediately this message, click the buttons to the left to see how the command pattern works. So that's our initialized state already executed. I can click pass and I get this message. So you can see our random number was put into the class private data in this save result, and that was extracted out down here. Same thing works with fail. Dialog, it gets the message I sent it, and then I can get a random fact. So yeah, just a simple example. But yeah, and you can add more methods, right? So if you look at like my project, my command class, which is the parent, only has a single execute method. There actually can be more to that as well. This is just, again, super simple example. Also, if you look at my execute, you notice that I'm outputting a string and just Boolean like true false for shutdown. You don't have to do that either. So there's not necessarily a rule on what gets output out of this abstract method. So it could actually output nothing, right? Every single action that each child might be implementing might just be it does something, but it doesn't actually ever output anything, and that's totally valid. And if you do need everything to be able to output something, then add it to the connector pane. So it's up to you kind of as the developer to design that how you want, but the idea is, right, we're kind of just replacing that cluster of string and variant with objects, and then we're using those objects rather than defining a whole bunch of cases down here to basically dynamically override the parent with the specific action we want it to perform. So yeah, that's pretty much the command pattern. This also is complemented by the channeling pattern, which we're going to make a separate video on, talk a little bit more about. But yeah, this is a really helpful object-oriented design pattern. Not as commonly used as like the factory pattern, but still really powerful, still used quite a bit. So yeah, hopefully that was helpful, and thanks for watching.
Canon Controls is your gateway to mastering LabVIEW. Dive into programming for data acquisition, industrial communications, and manufacturing automation. Explore how to enhance your projects with cybersecurity best practices. Join the journey to elevate your skills and secure your systems with every episode.